This video is for Lesson 2.2 Part B, and the two objectives for this lesson are being able to describe the end behavior of a polynomial function using words and symbols, and also being able to graph a polynomial function using a graphing calculator. And the first thing we're going to do is take a look at what end behavior really means. End behavior is a function's graph. It's the behavior of the graph as x values approach positive infinity. And here we have positive infinity in symbol form, or as it approaches negative infinity, and again, negative infinity looks like that. So when we draw infinity, it's just kind of like a number 8 on its side. It's a little bit easier to do as you do it more and more times. In other words, you are looking at the far left end and the far right end of the graph to determine whether the graph is heading in the upward direction or the downward direction. And we're going to sketch the graph of the polynomial function x squared. And we all recognize that one as the one that is just a parabola like this. Now, what is the end behavior of x squared? Well, we can say that as x approaches infinity, then the function itself approaches infinity as well. So let's look at the graph, and I'm going to point out a couple of things so that we can see what that means. And in symbol form, the function of x approaches infinity as x approaches infinity. So I've written it out in words, but I've also written it here in symbol form, and that's the one that you want to get used to. So the arrow really just means as it approaches that value. And when I was looking at the graph, when x gets bigger and bigger, so when x gets closer to infinity, guess what the graph does? The graph goes up, and therefore the graph itself is going toward infinity as well. And in this case, when x continues to go less than 0, or it gets closer to negative infinity, because negative infinity is way down here to the left, while this graph also goes upward toward infinity. So there's a couple things we want to take a look at and why the graph does that, and we're going to explain that on the next page. The end behavior of any polynomial function can simply be described by looking at the term that contains the leading coefficient and the degree of that term. And there are going to be 4 possibilities, and let's take a look at those now. All right, so a couple things that we have here on this page are the fact that we need to look at the degree of the polynomial, which we know the degree is the exponent here. And we also need to take a look at the leading coefficient, and that's kind of why we pointed that out in our previous lesson. We want to get familiar with what it means to have a leading coefficient. So the very first term of the polynomial function has a number in front of it. If it does not have a number in front of it, then it's 1. And the degree is going to be this exponent right here. So the end behavior has to do with those two things. If the degree is odd, meaning that it's 1, 3, 5, 7, and the leading coefficient is positive, the function is going to approach infinity as x approaches infinity. Okay? And then the other end is that f of x, the function itself, is going to approach negative infinity as x approaches negative infinity. So that's the case for any time we have an odd degree and a positive leading coefficient. So I'm going to make an example graph here. So as f of x approaches infinity, that happens when x itself approaches infinity. And that just means when we're going in this direction, the graph is going up. And when we're heading in this direction with our x values, the graph is heading down. All right, so this table will become helpful to you as you continue to work on some of these problems. So let's take a look at the next one over to the right. In this case, we're talking about having a degree that is odd. Okay, again, that's odd. 3 is odd. and a leading coefficient that is negative. In this case, we have a -2. So the end behavior is going to be a little different. First, I'm going to graph a function that would have a negative leading coefficient and an odd degree. It may look something like this. That's not a perfect graph, but you can get the idea. So for the end behavior of a graph like this, we would notice that as x gets bigger, okay, so as x gets closer to infinity, the graph goes down. So that means that the function is getting closer to negative infinity, going down, when x approaches infinity. All right, and then we also have on the other end, over here on the left, as f of x, well, f of x will approach infinity as x approaches negative infinity. So we have to think about this because as x, the value of x goes this way, what's going on with the graph? The graph is going toward infinity. Okay, so you have to think of what's happening in two areas. What's going on with x, and then what's going on with the function itself. All right, and then we have two others here. If we have a function that has a degree that is even, here's an even degree, meaning that the exponent is even, and there's a positive leading coefficient, we may have a graph that looks something like this. Okay, it kind of looks like the letter W. And in this case, because this is a positive value, notice that the arrows on the ends here are going toward infinity. And that's because, of course, the leading coefficient is positive. It's not negative. So when our x value gets bigger, what happens to the actual function or the graph? And when x gets smaller, closer to negative infinity, what happens to our graph then? So let's write this out in symbol form. The function f of x gets closer to infinity as x gets closer to infinity. And when x goes closer to negative infinity, the graph also goes toward infinity. All right, and some of you with a photographic memory will probably just remember the graph itself and be able to think about, okay, well, when x gets bigger, the graph goes up. When x gets smaller, the graph goes up. When I have a even degree function and a positive coefficient. So there's going to be a couple things different when we look at the next graph, the last graph here. And if the number in front, the leading coefficient, is negative, then of course we're going to have a downward facing graph, as we learned about those parabolas last semester. When there was a negative in front of our function, then the graph was downward facing. And this time, as x gets bigger, what's going on with the graph itself? It's going down, so it's getting closer to negative infinity. And when x gets smaller, over here, the graph is also going in the downward direction. So that's what we are talking about when we're talking about end behavior. So the function itself gets closer to negative infinity when x approaches infinity, and f of x gets closer to negative infinity as x approaches negative infinity. All right, if you have questions about this, make sure you ask when you're in class, and we will do a couple problems together, of course. And you'll need to make sure you ask specific questions because this can be a little bit complicated when we first start out. So without even graphing, I would like you to describe the end behavior of each polynomial function using symbols. And in problem A, the first thing we want to do is check and see, is this function written in standard form? Well, I see that this has an exponent of 5, and that really should be written as the first term. So I need to rewrite this, so I have positive 3x to the 5th minus 16x to the 2nd. And the reason for that is once we get it in standard form, then we can tell what our leading coefficient is. Our leading coefficient is positive, but the exponent or the degree is odd. So if we go back up to our table, we want to find the positive leading coefficient and the odd degree. And that looks like, it would look kind of like this one, and that's what the end behavior is going to be. So we want to answer problem A with this information. So as x approaches infinity, the graph goes up. As x approaches negative infinity, the end behavior will be going toward negative infinity. All right, so go ahead and write in your answer as I did here. Remember, f of x is going toward infinity as x does, and so is the function going toward negative infinity as x goes toward negative infinity. So we want to take a look at the next problem, problem B, and that says that 10x to the fourth. Well, that's easy because there's only one term. Remember, the end behavior is based on the leading coefficient, is it positive or negative, and the degree. The degree for this one is even, and the leading coefficient is positive. So when we go back to our chart, we can tell what the end behavior is going to be because we have an even exponent and we have a positive leading coefficient, so our graph will look something like this, and therefore we can use the end behavior that we have on this chart. As x gets bigger, so does f of x, and as x gets closer to negative infinity, so f of x gets closer to infinity as well. All right, so there is our answer for that problem. And for part C, I think I'm going to have you do this one on your own. Try it out. Remember that the function needs to be written in standard form first, so make sure that this is your first term because, of course, that's going to be the highest exponent that you have. The largest exponent goes first. All right, so rearrange it a bit before you start. On the next page, we have example 2. I'd like you to describe the degree and the leading coefficient of the polynomial function whose graph is shown. So when you see a graph like the one that we have here in problem A, if x is going positive and the graph also, the function itself, is getting closer to infinity, then what does that mean when, as we go toward negative infinity, as x gets closer to negative infinity and the graph continues to go up? Is the degree odd or even, and is the leading coefficient negative or positive? Well, we can say that the leading coefficient is going to be positive because the entire graph is going upward. All right, and then we can say that the degree is going to be even, and the reason that we know it's even is because there are an odd number of ups and downs. If you look here, there is 1, 2, 3 places that it turns, the graph turns, and therefore this is an even degree polynomial. All right, let's take a look at problem B. And again, we need to describe the degree and also the leading coefficient. Well, if the graph is going down here as x gets bigger, and as x gets smaller, the graph is going up, then we know that there's an odd degree. And the reason there's an odd degree is because if you look here, the graph takes 2 turns. And the degree is going to be odd because there's an even number of changes in its direction. So again, the degree is going to be odd, like 1, 3, or 5. And the leading coefficient has to be negative because the end of the graph is going downward. Okay, so if you were thinking of a linear graph with slope that's negative goes in this direction. And so we can say that our leading coefficient is going to be negative because at the far right part of the graph, we are headed toward negative infinity there. All right, let's take a look at problem C. Problem C is a positive sloping graph on its way out. So toward the far right side of the graph, this graph has a positive slope, and therefore the leading coefficient has to be positive. And how many turns does this graph take? Well, if you look carefully, there's a turn downward here, and then there's a turn upward around this area. So if there's 2 turns in the graph, then that means that the degree is going to be odd. So depending on the number of changes in the graph's direction, then that's going to be the way that you can tell what the degree is, or what the exponent, the leading exponent, is going to be. All right, I'm going to let you try problem D on your own, and just take a look at your table on the previous page, and you should be able to figure out both the leading coefficient and also the degree. So the last part of this notes we're going to have to do in class. So the graphing polynomial functions, we are going to need our graphing calculator, and we are going to be using the table menu, and you may remember that just a little bit from the previous semester, but we're going to do some practice on that tomorrow in class.